Hi, I'm Mr. Richmond. This is your Integrated Math 1, Unit 6.4 Lesson Summary. Unit 6.4 just kind of summarizes everything we've done in the chapter and helps you come up with some strategies to decide and choose the method that is easiest to solve different word problems in the chapter and different systems of equations in the chapter. So for our lesson, it'll be kind of a short video because I'm just going to summarize when it is best to use these three. You will have some test questions that ask you to describe when each of these situations best. So you can kind of look at the summaries here, practice going back into the book and looking at some different systems and seeing how you would solve them based on these recommendations. And you also need to be able to compare some graphs in section 6.4, compare some situations using graphing and things like that, but you really don't need any new skills. So I won't be doing any sample problems for this section. So when is substitution method the best method for solving? Substitution method is best when you already have one of the variables in one of the two equations solved for you, or you can easily solve for one of those variables. So I wrote two examples of when I think substitution would be good. In this first one, substitution would be a good choice for a solution method because you already know what y equals and can very easily just plug it into the other equation to solve the system. So that is one example of when substitution would be a good choice. Here are the ones where the decision you make is a lot more important. Here it's not written in any great order. They're not both in standard form. I don't even have a variable solved for yet. But as I look at it, y here isn't all that difficult to solve for. I just have to divide by 2. So I would recognize that, rewrite it. Really only took one step, and now I have the ability to do my substitution. So that would be another example of a good one to solve by substitution rather than any of the other options. Okay? Our second option is elimination, or a lot of times you'll see it in the book or in other books or the courses being called linear combination. It's the same method. That is best to do when your equations are written in standard form, or very easily with maybe only minimal movement be put into standard form. So for the first one here, they are exactly in standard form. X's are lined up, Y's are lined up, constants are lined up. I would want to do elimination here. May take some multiplication to make it work, but since this is the form it's in, I like to flow with that form. For this particular one, they're already lined up, ready to go, and are in an eliminatable position, and I can solve for X fairly easily, plug that answer back in, and get a solution. For the second example that I would do elimination on here, they're not necessarily in a great order, but as I look at the variables, you might think, oh, do substitution here, because you can get x by itself by dividing by 2. But when I do that, when I divide by 2, I'm going to get fractions, 7 halves plus 3 halves y, and then have to circle that and substitute it in, which means you're going to have to do a lot of operations with fractions, multiply the fractions, subtract fractions to try to solve, and that might be more work than we want to deal with. So, since the substitution method would have produced fractions, I'm going to go with elimination because it's not going to be all that difficult. The bottom equation is already in standard form. I just need to move the top equation around to make that happen. So if I subtracted the 3y over and rewrote it, it would be 2x minus 3y equals 7. And just with that simple subtraction movement, I've now placed them both in standard form and can fairly easily do my elimination. Just have to figure out what to multiply them by. Okay? So hopefully that helps clear up when you should use substitution compared to elimination. And in addition to being able to choose that and solve problems on the test, you also need to tell me in words and complete sentences when you should use these. So really focus on when it is most beneficial to use them. And the last one, graphing. For most people, graphing is really only the best option when you are being asked to compare two situations. It's usually in the word problems where they give you one business compared to another business, or one person's cost or what they charge compared to another person, and trying to see who the better deal is. By graphing it, you get a much better idea of how to answer that, because you don't just find the intersection point that way. You can actually physically see when one option, let's say option A here and option B, in this situation option A costs more until they meet, and then from then on option B costs more. So whenever I have these problems that are asking me to compare the two equations or compare the two situations, graphing is going to be better because it lets you not only see where they are equal and where they cross, but also see which one's a better deal at certain times. So that's when I would do graphing. But graphing can also be used if you're just particularly good at graphing. You're good at graphing linear equations. They're not very complex. If you feel like you can graph them and find the intersection point just as quickly as you could do one of these two methods, then graphing is a good option for that as well. Okay? So hopefully this helps you helps clear up when to use these different methods. Definitely focus on this section and go back and look through and make sure you know how and to choose the best way to solve it, because it really will make this test a lot easier and help you get through things much smoother.